Hello everyone, welcome to you in my YouTube channel. And today this is the part 2, second video on this chapter real numbers. And today I'm going to discuss about proving square root 2, square root 3, square root 5, etc. as irrational. So and this is, I'm saying it is a pure radical. Radicals means it may be square root, cube root, fourth root, fifth root, and so on. This is called radical. This is one type of question. Mostly in examination they are asking. And second type, that I am telling mixed radicals. So it is like this: 3 plus 2 is square root 5. 5 minus 7 is square root 3 by 11. Square root 3 plus square root 2, square root 3 plus square root 2 whole square. So this is only two types of questions they will ask in examination. So today I am going to prove that square root 2 is irrational. And we will use contradiction method. Contradiction method means, suppose it is a board marker, and if you want to prove that it is a board marker, so how we can use contradiction method? Markers are two types. One is board marker, one is permanent marker. So we will suppose opposite of that. So numbers are two types, rational and irrational. So we want to prove that it is irrational number, so we will suppose opposite of that. So let us assume that square root 2 is rational. So I suppose it is a rational number. And all rational numbers can be written in the form of fraction. So I wrote it in the form of fraction. And I was telling about the contradiction method. So this is a board marker. Suppose opposite of that. So suppose it is a permanent marker. Both markers are writing. So I will write something. Suppose I will write Rahul and apply, because whenever we are writing, if you erase it, suppose this, I suppose it is a permanent marker, but when I erase, it's erased. It means does not contain the property of permanent marker. So hence it will be a board marker. Same thing we will do here. After that, write where A and B are co-prime integers and B is not equal to 0. After that, it is square root 2 means square root 2 by 1. Square root 2, square root 3, square root 5, square root 7, square root 11, square root 13, and so on. You can prove by this method only minor change. In the place of 2, 3 will come. In the place of 2, 5 will come. But all steps will remain same. Now just do cross multiplication. A into 1 is A. It is square root 2B. Next step is squaring both sides. Now you square both sides. So it is A square. And when you will square this, root 2B whole square, this is equal to 2B square. And it is equation 1. So A square is a multiple of 2. You take any value of 2 and then calculate this. That must be the multiple of 2. You take B as 1. 1 square is 1. 2 ones are 2. If you take B as 2, 2 square is 4, 2 are 8. If you take b as 3, 3 square is 9, 9 to the 18. See, all these numbers are multiple of 2. It means a square is divisible by 2. So right here, 2 divides a square implies that 2 divides a by theorem 1.2. Theorem 1.2, when a prime number divides an exponent, a square is, this is a square and it is divisible by a prime number. If a prime number divides an exponent, the value of this exponent, then 100% that prime number will divide the base of that exponent. That is theorem 1.2. So here I wrote 2 divides a square because a square is a multiple of 2. So 2 divides a square. 2 is a prime number, divides an exponent. According to this theorem, then 2 will divide the base of that exponent. So what is a? 2 divides a. A means 0, 2, 4, 6, 8, 10, and so on. 2 divides a, a may be 0 because 0 is divisible by 2. It may be 2, it may be 4, it may be 6, it may be 8, it may be 10. So how to say all these numbers together? Now we can say let a equal to 2c. If you take c as 0, then you will get 0. If you take c as 1, 2 ones are 2. If you take c as 2, 2 twos are 4. So 2c represent all multiples of 2. That's why we took a equal to 2c. From equation 1, substitute this value of a in equation 1. So it is 2c whole square equals 2b whole square. So 4c whole square equals 2b whole square. 2 ones are 2 twos are. Now b square is equal to 2c square. Now b square is a multiple of 2 because c square like that one. So next step you can write, it means because b square is a multiple of 2, so 2 divides b square implies that 2 divides b. This is also because of theorem 1.2. So this is second equation and it is third equation. A and b are co-prime integers. Co-prime integers means they are not divisible by common number other than 1. For example, if I will write 3 and 8, 3 and 8 are co-prime integers because 3 and 8, they are not divisible by any common number other than 1. So co-prime integers doesn't mean that both must be prime. Co-prime integer means they don't have common factor other than 1. So equation second and third, from these two equations, 2 divides a, 2 divides b. So a and b both are divisible by a common factor other than 1. That it means they are not co-prime. So here you can conclude your solution. Second and third contradicts that a and b are co-prime. A and b are co-prime integers. Hence our assumption is wrong. So root 2 is irrational because we suppose it is rational and it is wrong, so it will be irrational. Similarly, in case of square root 3, you have to, in case of square root 2, what we did? Conclusion, we proved that a and b are divisible by 2. If square root 3 will come, then you have to prove that a and b are divisible by 3. Similarly, square root 5 will come, then it means you have to show that a and b are divisible by 5, and so on for any square root of any number, 7, 11, and so on. This is first type of question. Now second type one is, I will do second type. Question, next question. Prove that 3 plus 5 root 7 is irrational, or here you can write 2. It is given that square root 2 is irrational. In your textbook, just they are writing till here. Prove that square 3 plus 5 root 2 is irrational. It is given. But in board examination, they will write this. It is given that square root 2 is irrational. If it is not given, then you will prove like this only. So same thing, we have to show that it is irrational. So let us assume that 3 plus 5 root 2 is irrational, is rational. Because you want to show that it is irrational, so suppose opposite of that. So I suppose it is rational. And all rational numbers can be written in the form of fraction where a and b are co-prime integers and b is not equal to 0 because denominator never equals 0. Not possible. Now 3 plus 5 root 2 means by 1. Then you do cross multiplication. A into 1 is A, or you can do this one. B into 3, that is 3b. 5 root 2b equal to A into 1. And this one is easier than square root 2, square root 3, square root 5, and 7. Now just you make this as subject. In other words, I can say find the value of root 2. Suppose root 2 is x. So find it by transposing terms. 5 root 2b equals a minus 3b. What we are doing? We are going to make square root 2 as subject. So by transposing we can make. So now square root 2 equals a minus 3b by 5b. Now we can write left hand side is irrational. Why? Given. It is given in question. Right hand side is rational. Why? Since a and b are integers. In a fraction, if numerator and denominators contains integers, that fraction must be rational. So a is integer, already we suppose 3 is integer, b is integer, 5 is integer, b is integer. That's why this whole thing will be rational. So it is irrational and it is rational. They never equal. So LHS is not equal to RHS. Hence our assumption is wrong. So 3 plus 5 square root 2 is irrational. So remaining question of exercise 1.2 you can do in your home by using both methods I told you. So today's lesson is over.